Hey physics fan, we're going to look at a couple examples of the universal law of gravitation, and we're going to be using the universal gravitation constant. Just a quick recap, there is a formula that can be used for all gravity, and that is that the force of gravity is equal to this constant, which Henry Cavendish thought of, times the mass of the first object times the mass of the second object, divided by its distance squared. Also remember that the actual gravitation constant is a certain set number, that is 6.67 times 10 to the negative 11th. And it has a bunch of units after it. Remember, all those units end up canceling out so that you're left with just the units that you need. So if we look at number 1 from our 6-1 worksheet, excuse me, Mrs. Borst, who has a mass of 60 kilograms, is doing a physics demonstration in front of the class. Let's do part A first. Part A says how much gravitation force, so first of all it's asking for how much is the force of gravity does she exert on a 55 kilogram student named Lauren. Okay, so Mrs. Borst's mass, we already know from the first part, is 60 kilograms. The second student's mass, or Lauren, is 55 kilograms. And because they are sitting away from each other, they have a distance between them of 1.5 meters. All right, you have all the information you need in order to figure out the force of gravity. To do that, we're actually going to use this equation that we already wrote out. Okay, so we have our unknown, it's force of gravity, and we have all that is given to us. So let's go ahead and solve it and plug in. My force of gravity, which is what I'm solving for, is going to be equal to my big G, which happens to be 6.67 times 10 to the negative 11th. And then I'm going to multiply that by my mass 1 and mass 2, which happens to be 60 and 55 kilograms. And then on the bottom, since the distance is 1.5 meters, it's going to be 1.5 meters away. And don't forget to square it. The squaring is important. Remember, distance affects gravity through the inverse square law. So as you get further away, inverse square of that would tell you that the gravity decreases. If you get closer together, that just tells you that gravity would increase. Anyways, when you plug that out and chug that out through your calculator, you end up getting an answer that should be equal to about 9.8 times 10 to the negative 8th newtons. Now, is that a very large number? Absolutely not. Should it be a large number? Absolutely not. The force of gravity between two people is so ridiculously small. And again, this is to the negative 8th, so this is a very, very, very small number. It is negligible. We can't even notice it. Why? Because the Earth's mass is so large that it's creating much more of a gravitational pull on us. All right? But at least this is an example where you saw how it was plugged in to find the force of gravity. The closer you get, and of course the more mass you get, the more the force of gravity will be. Now, if you wanted to answer part B, you would do the same exact thing, but plug in 65 kilograms for the new student with a new distance of 4 meters. So you'll see that even though this student might be 15 kilograms heavier than the previous student, Lauren, with being 4 meters away, that's going to be a dramatic decrease in gravity, and therefore you should see that B will end up being smaller than A. I hope everything then made sense. Continue to work on it and make sure not only do you understand the math behind it, but the concepts that mass increases gravity and the distance, if it gets greater, decreases gravity. All right, physics fan, keep on trucking.